Hey everyone, today we're going to wrap up creating a Docker file for Db2. If you didn't watch the previous episode, you're going to want to go back and quickly review it. It is going to give you the terminology and basic concepts that you need to write a Docker file. And these are completely different than the Docker Primer series that I did a little earlier that shows you just how to function with Docker. There's a difference between being able to function within it and writing a Docker file or creating an image. There are going to be two different types of people that are watching this video today. And it's going to be either the person that just wants to understand how to write a Docker file, in which case this will apply, or it's going to be a DBA that wants to understand how to create their own Docker file so they can create their own image and their own outcome. And as we go through this, I'm going to be speaking to both. Now, if I took the DBA component out of this video would be a lot smaller. Because we're going into how we want to configure things and creating a database and how would we do it if it was part of a larger virtual stack, I have to go into a little bit more detail on what to do and what to watch out for. So if you're here on just how to create that Docker file, you could get through the main Docker file section where I'm actually going through line by line on what to do, and maybe a little into the entry point, and you would be good. If you're a DBA, you're probably going to want to watch all of the coding example. And regardless, at the very end, I went through and I picked out everything that I thought was important. Those are the high level things that you really need to remember this or it's going to break. And I put it into about 5 or 6 slides that I will quickly review with you to say, watch out for this, do this, make sure you have this done. That way, if you finish this 45 or hour long program and you need to come back and just refresh, instead of trying to remember where we were in the code, you can go to the end and just go to those slides and they should give you what you need. Depend on your timestamps here. This is going to be a lot longer than normal because I wanted to show you everything from soup to nuts. And I'm approaching it as if you and I were sitting together at work where I needed to sit down and say, all right, here's my code. Let me go through section by section by section and explain to you what I did and why I did it. All right, we've got a lot to cover. You ready? Let's go ahead and go over into the code. Before we start tearing apart the scripts, I want to point something out. And that is, I have everything I need in one location, one directory. I will always be working from this one directory. And it includes not only my Docker file, which does the initial big build, but it also has the scripts that I call for configurations later on. It also has the binary file that Db2 is going to end up installing from. When I first approached this, I was a little confused because I'm like, I understand that the script needs to be here, the Docker file, but where the heck do I put my binary files to do the installs? And the way you can look at it is this is almost your staging area. When you're doing an image build, you can think of it almost as if that's the server and this is your desktop. And that any work I'm going to do, I have to copy over to that server before I do work. Because we're doing it in an automated fashion in this image build, I need to have everything in one central location. So when I go to command line, you'll see I'll go to desktop and Docker. Let's take a look at the actual scripts. So in my project over here, I have basically everything that I would need, and we always start out with a Docker file. The Docker file is going to be the main lowest common denominator. This is the basic of what I want to do. I want to install something. I want to launch something. This is the base building block. Now, be a good steward. I commented the heck out of this, and if you're going to do it, I would ask you do it as well. Make comments like, hey, I know you're new, but did you know if you're going to build something from this Docker file, you need to go download this file. Go tell what prerequisites you need to do, what's going to be handled, what's not. I ended up making general comments on how I'm going to even build the file, how I'm going to create a container, and how I'm going to get into the container. And after we go through the scripts, I'll show you what each of those mean. The first thing that you need to start with is from. When I approached this, I was confused. I did something called from scratch, which meant, hey, I'm starting with nothing. Well, that's not really true. You're starting with an operating system. So in most cases, you are starting from another lowest common denominator. In this case, I'm saying from go get the CentOS image. And that's my base operating system. I want CentOS 7. It's a very stripped down version of CentOS. This is my first building block. So don't go in thinking you're going to do from scratch. You're probably going to be building from something else. Maintainer is actually a command, but it's deprecated. This is just carried over from when I learned a few months ago. It's being replaced with various tags, so you don't necessarily need it here. Now, as we go through this, you may be watching because you want to learn how to do a Dockerfile, but I'm also going to be talking to those that that are DBAs, that want to set up a Db2 Dockerfile. So I'm going to go a little into the weeds, but it's still going to relay a lot to those that just want to learn about the Dockerfile. So I have my operating system. That's great, but if I try to do an install right now with Db2, it may be saying, hey, you're missing C, or I don't understand what you mean when you are trying to unzip, because that command's not here. So I went and got the Db2 package requirements. If you go out to how to install Db2 at whatever version you're looking at, I'll say here are your package requirements, and they're usually the ones up here at the top. What I also did is added things that I know I would use or that developers came and asked for. For example, hey, can you put OpenSSH there so we can get to another server, so we can SFTP? Can you put on zip there as well as sudo and a few other pieces that we need? Sure. So in this area, I am actually using the yum install command, which you should be familiar with Linux. I just have to preface it with run, and you can assume your root in this case. So I'm saying go out to the Linux operating system, run yum install. -y means yes, install all of these. Don't prompt me for it. Remember what I taught you about before. You're building in layers, so sometimes the command can get really long and unreadable. This is all one long command. I'm just using this backslash to make it more readable. At the very end, though, you're going to see I'm stringing together another command, yum clean all. So I made one long command here, from here to here. It's essentially two. I made it more readable with the backslash. I am making it one long command by using the and then I'm doing another yum right after it. When I go to install Db2, you have to remember to copy over what you need. Remember the analogy I said about your desktop and a server. It's not uncommon to have FTP, the binaries for install, over to the server. Think of it that way here. The image goes, hey, I know I need CentOS. Well, that's great. Now you're saying copy the binaries I need to do the installation file from the Docker folder that you're reading everything from and put it into the image you're about to build, the CentOS. So that is what the copy command is. Look where you are for this file and copy it over to /tmp in the image you're about to build. Once that's done, we're going to give it the command to go ahead and install. This could be 2 or 3 separate commands. If you think about it, I've got to cd to the directory I want, I got to untar my files, I've got to run the install commands. I'm making it one long command here. So run, change directory over to temp in your new image. And I want you to untar the binary we just moved over, switch over into a corn shell, or pardon me, shell, so you can execute the db2 install command. The db2 install command is deprecated, or is about to be. This is, in fact, I've been doing this 18 years. I'm still using what I know. You could go figure out db2 setup or another way to do it, or install from a response file. I just went with db2 install because that's what I know. And I'm passing it all of the commands that it needs to get going. To come up with that, I actually downloaded or pulled the CentOS Docker image, just base, and moved the files over there and started going through how do I just install it? What prompts do I need to answer and what are the answers to them? That's how I came up with this here. And I want to go ahead and install it into, I want to install it and leave a log. The other thing that would happen sometimes is there was an acceptable warning at the end, like, hey, this isn't set up for pure scale. Well, I don't care. But that could cause an alarm, or it could even cause the image to fail when you build. So you're going to see that, hey, at the very end, I'm saying just let the end user know that things were installed and there was an acceptable error. Once that's complete, use the run command to remove my original binary file. That's something I want to make sure you remember. Your image will get huge if you don't clean up behind yourself. Did you move over a big file and you don't need it anymore? Get rid of it. Did you expand it? Get rid of it. That's where you're going to make it more manageable for the end user. So to install Db2, copy over what I need, string a bunch of commands together in a single run to do the install, and I did another run to clean up behind myself. This part's a little important. Best practices to me bled over here, and that is with Db2 I always try to separate out my file systems so they are mounted separately, running separate disks, so we don't run into contention. And just to drive that home and to show best practice, you're going to see me do it here. Do I need to? Nope. You could not create any special directory, but I wanted to make this usable. I did two separate things. With the run command, I said, go make me these separate file systems. And I found out I didn't have to string anything together. If I just typed them all out with a space, it made all of them for me. And this makes more logical sense to me when I log into the container. Once I'm done with that, I went and made it persistent. I essentially made a mount. I want to point this out here. This goes a little against what Docker is all about. Docker is ephemeral. It's meant to be torn up and tear down and built up, and it's not meant to be permanent really in any way. But when you're dealing with a database, it's permanent. It's just not permanent long time, right? I may be permanent for a week. I may be permanent for a month. And if the container is shut down or abends and you do not have volume persistence or essentially a mount, whatever you had there disappears. So when I came at this, I said, what's the minimum I can do? Well, I just want to save my data, right? So at first, all I had was volume data. And that allowed me, if it stopped and came down and came back up, my data was still there. Well, I said, maybe because this is under so much change, I need to be taking a backup daily for the developers just until this POC is done. Well, to do that, I need to make sure my backup file system is persistent. Well, if I do that, then I'm going to need logs. Well, what if later on I need to upgrade Db2? Well, maybe I should do. Finally, I went back and said, you know what? Forget it. If I would make it a separate mount in production or even in development, I would make a separate mount here. And this actually just saved my butt. About a half hour ago, when I was working in my Docker container, I fat fingered a command and accidentally closed my terminal window and basically brought it to a halt. Came right back up without a problem. So with the file systems, we're going to make them first, then you declare the volume, which makes them persistent or a mount. I'm opening a port 50,000 for Db2. You do not have to do this. This just prevents you from having to type a command upon run each time to open up the port to listen on. Entrypoint. Now, we could stop here. If we stopped here and we put in some sort of command that says, do this continuously after your build, that is, tail this log just permanently, this would run and build and you would be fine. However, I'm saying this is my lowest building block that I may change later on. And I have done other configurations in other scripts. And most of the time, you just hear about Entrypoint. which is a single script that you create that does things that you want. But in my specific situation, I have configuration that is best practice for any type of database, but then I also have configurations that are best practice if it's, say, a warehouse or OLTP. So where most people would stop with a Dockerfile or with a Dockerfile and an Entrypoint script, I am actually doing a Dockerfile, Entrypoint script, and another configuration script. When you're doing your Entrypoint, it's just like your binaries. You must copy your script over into the temporary directory that you're going to use. Once that's done, I learned the hard way that you need to open up permissions, otherwise you're going to get strange errors on build. To call the entry point, to essentially hand off from one to the other, is the entry point command and specify your script. Once that's done, it's going, I know I'm done here, let me pick up the next step. Now, what it doesn't realize is even after that, entry point's going to say, I'm done. I'm going to call even another script. So if you build another component on top of this, you follow the same behavior, copy over into temp, change your permissions, and end up calling it later in the other script. The entry point script. A couple things to point out here. First of all, the entry point script can be whatever you want it called and in whatever language you want, as long as you're specifying it in your Dockerfile. So my Dockerfile specifically ends by looking for env_script.sh. I'm purposely writing in Corn Shell because that's, to be honest, all I really know. I made a couple comments about, hey, there's variables at the command line when I hit the run command that are going to be passed throughout the script and used. And matter of fact, one of those is going to end up going even further into my last script. And this script is pretty much where most people would end. In my specific case, like I mentioned, I have the generic best practices and the specific best practices. So let's roll into it and see what we have. I don't have to explain anything here that's specific Docker related. However, if you are here to learn about how to build a Docker file and you don't care that this is for a database or a DBA, pay attention to the very end of this section. When I get to the very bottom of the entry point script, there's something you need to pay attention to. Otherwise, I'm speaking mostly to the developers or DBAs that want to know how to set up a database. So I'm not going into the details of Docker or Corn Shell. I'm just going to explain what I'm doing. The first is, why am I even starting a date or putting a timestamp? And that's because I realized when I am doing a build, it takes a little bit of time for the scripts to finish. And in some cases, I was trying to get in and do things before the container was actually completely built, because it'll let you in there while it's still doing work. So doing a start date and end date at the time, that timestamp told me exactly how long this was. So on average, I knew to wait for 30 seconds. And that's something else I need to point out. If you have a container that is started or stopped and then started again, it will run these scripts every time. And that's important, because when you're coming in here, the best way to get started is just do the basics. If you're coming in and all you're trying to do is set 5 DB configs, and that's a one-line command, just do that first and make sure it works. But you're eventually going to want to go from the functional to the more dynamic and more hardened. The reason I say that is, if this is started and stopped and you have volume persistence, you may be trying to redo things that don't necessarily need to be done and you're wasting time. That also comes into play if this is part of a larger virtual layer and they're starting and stopping things at a stack level. Is it okay that your script is running every single time? So you're going to end up starting with just make a change to this configuration, and for something on your desktop that's going to be fine. But remember, with a database, your database isn't as ephemeral as you would like. It starts and stops. It may be around a week, it may be around a month. So if it stops or abends, can we recover easily? And you got to make your scripts handle that. And what you're going to see is, all right, I've got to go through and do all the basics, but everything's within an if-then. Detect it. If it doesn't exist, then create it. So for example, first thing I have to do is I've got to create a group for the Db2 instance ID. Go out there in the groups. If it doesn't exist, go ahead and create it. Otherwise, skip the step. Once you're done with that, go out there and look at the ID that I want to give you as a generic user to go ahead and query later on, not necessarily an admin. Does it exist? No. Go ahead and create the group and the user. And then you can go and set the user's password. Then I'm going to come down here, profile creation. This is specifically because of Db2. I found that if I just had a real plain Jane install and everything was stripped down, and I got to the point where it wanted to do an iCreate, but the .profile didn't exist already, it wouldn't create it. It just skipped the part where it tells the instance ID, this is how you go call Db2. So I went out and said, go ahead and create Db2 inst1, throw it into the proper group. Then I want you to just touch the profile, create a profile, and open up the permissions. There's nothing in there at all, but it makes it easier when you do the iCreate. iCreate will go out there, oh, my profile exists, let me slap in there what I need. And then again, I'm going to change the Db2 inst1 password to something that's useful for you. The file system ownership. This is something you probably wouldn't need if you're doing this just on your local. But again, if things start and stop, especially when we had it in the stack virtual layer, sometimes permissions would get dorked and all of a sudden I can't get to my data. So upon startup, I want you to go out there and do a check. Does it look like it should? If not, change the ownership and permission to where it should be. Now, we've created Db2 inst1, right? I'm going in and now I'm updating the profile just for my own usability. I'm going in there and saying, hey, can you make sure to give me command line recall? And I want to see the host name on my command line. Basic little things that make life easier for me. If you wanted to do a clear or a splash screen, you can throw that in here. Oh, I take that back. I didn't do the instance creation yet. I'm doing it here. So my .profile exists. I've already put in my usability settings. And now I'm saying go out and switch over to the instance ID. Remember, you're essentially root. This is a root installation. And then I want you to go ahead and create the instance. Db2 iCreate with the fenced ID, and Db2 inst1 is the instance ID. I also went and ended up putting in the port that will be referenced in the DBM CFG into the etc services. If I come down a little further, now this was interesting. This was specifically happening not when we were on our desktop, but if we were trying to put things into a virtual area, a virtual stack where we were a piece of a whole. Sometimes when things were stopped and started, we saw that we would sometimes lose our ports. So we ended up just making it so we could put them in every time. Go check it, and if it doesn't look right, go ahead and add it. IP clean. Again, this is something else from an abnormal shutdown. We were finding that theoretically, if the server crashed on you, right, it would start back up and go through a crash recovery. What I was finding is that Db2 was so hosed from a container stop or an abnormal stop that it couldn't even get to the point where it would clear its head and try to do a crash recovery. So regardless, I'll go out there and say issue an IP clean. Boom. Because remember, this happens every single time we do a stop and start of the container. So we've cleaned memory. We should be okay if we had an abnormal end. Let's go ahead and apply the universal database changes. I'm not going to walk you through every one of these, but I'll show you the logic. Essentially, I went and got everything I wanted, found out what it's set to, and then did an if. So for example, go out there as db2 inst1, find what my db2 diag path is, compare it. If it's not what it should be, then I want you to go into db2 inst1 and do an update. And it's doing that for everything that I wanted to adjust, from my db2 diag log to what I'm monitoring, to my health monitor, to where my default database path is, my service name, my auto start, TCP IP, is that set? I want to make sure parallel IO is set on. All of that needs to be done. Now, I note the time, and I'm going to skip over this for a second and go to the bottom, and I say tail the OS error log, essentially. Why am I doing that? Because this may be moved up into your Docker file. Docker will do exactly what you tell it to do and then stop. So if you say go build this container, and that container is supposed to go get CentOS, copy over the file it needs, and install db2, it's going to do just that, say I'm done, fantastic, let me stop. And so you see the container's there, but it stopped and I can't get into it. Why can't I get into it? That's because it did exactly what you asked. However, if you end things with go continuously monitor this log over here, which is always written to always open, it'll say, okay, so here it's going and doing get CentOS, go ahead and do the db2 install, go make all of these changes if they haven't been changed before, and then I want you to sit there and watch this db2 error, this OS level error log. It's going to be open the whole time, and if it's open, just keep everything running. So it'll go, okay, I've done everything, I have no more to do, I'm leaving the container in a running state. You can come in and poke around if you'd like. All right. This is where I was telling you, if you're here to just learn about Docker, you could stop right about here. What I want to show you here is if you end up having another script you're calling. Remember what I said, the next script is going in and setting up very specific configurations for something specific, like it's WebSphere Commerce, or it's going to be a warehouse or transaction processing. So here I have to do two things. One, if there was a variable that was passed a command line in the very beginning, it has to continually be passed on, right? So it went from the Dockerfile, it's over here in the environment script, we haven't used it. I need to tell it, go ahead and export it again so you can use it in the next script. Then I want you to switch over to db2 inst1, and I want you to use the db build script to start doing this very specific configuration. All right, so we're in the last phase, or the last script that I used. Just to review, the very first Dockerfile is the base block, the lowest common denominator of install db2. I went over to my Entrypoint script, and my Entrypoint script basically gave me the proper IDs I needed, created an instance for me, and did some basic best practices and configuration. And once that was done, we specifically said keep the container open by tailing this log so we can enter into it later. And then pass over to the db build script. And in the very beginning, when somebody's typing out the run command, they can create me a database with this database name. And if we have that provided, it will go into this build script and create it. just like the others, the first thing I did is created a timestamp to show me that we started this script, and I have a end timestamp at the end so I can gauge length. First thing I did after that, I should say, I ended up typesetting the database name. This is just out of habit. If you do a create database name in lowercase, it may uppercase it for you, but out of habit I did an uppercase on it, and then we ended up calling the Db2 profile so we can execute Db2 commands. First thing that we're doing is we're checking, is Db2 even online and active? If not, go bring it online, because we can't do anything until it's there. And then I want you to see, did the end user supply a database name? If they did, great, we're going to move forward. If they didn't, exit. And so I could theoretically break completely out of my program, which is why that you see we do our tail at the very end of the Entrypoint script. The command that keeps the container open is going to be an entry point, not this third script, which may or may not end in the middle. If I am moving forward, I need to see if that database existed already. If it exists, we're going to bypass it. If it doesn't, we're going to create it. So once the database is created, then we go and look at some base configurations that I would put in play. These are just some that I had suggested for a local install, but I ended up using a litmus test. So instead of doing an if-then for every one of these, I made the assumption that if my lock timeout is not at 60, then probably everything else needs to be set to go ahead and make the changes. After that's done, we actually do a test up here. See where it says bounce 1? When we made all these changes, and matter of fact, we changed how we do log archiving, I said at this point in time, we probably just need to stop everything, take a database backup to make it happy, and reactivate the database, which is what we're doing here. Make everybody go away, turn the database off, back everything up to dev null, the bit bucket. I don't care for the backup, get rid of it, just do it as fast as you can, and then activate the database. Once that's done, again, I go into another litmus test and say, you know what, if I don't have 32K table spaces, I probably didn't do any of these create statements. So go ahead out and take a look and create the buffer pools and the table spaces for me. And at the very end here, take the DB user that was passed on to us and go ahead and grant access to the various table spaces and the ability to connect. Once that's done, we're done. So go ahead and terminate, and you're good. What you're seeing down here at the tail end was the rest of that if statement that basically says, oh, the database may already still be up, or the database already exists, and it's the if then and then the skip of it. And then at the very end, we end up leaving a timestamp so we can see how long that it would take. This is shorter than the one I created for work, which is a lot more in depth, but the one that I'm using at work from the type of command run, run, to when the container is absolutely completely built. That is, I did the Dockerfile, I've done the environment setup, and I did this. Every step was about 1.5 minutes. So take a look at how long it will take these to go through, because you can accidentally get into your container and start typing commands before it's completely set up. Now that our Docker file is squared away, as well as our scripts, let me show you exactly how you go about compiling the Docker file, as well as running and executing the container. And then I'll show you some special things that I did with my logging to track what was going on when. So the first thing I need to do is go to the file system that contains the Docker file. And I know that's going to be on my desktop. And then it was under Docker, I believe. Docker. Alright. So here are all of my files. And like I mentioned before, make sure you have the binaries that you want to install there. And I've already kind of gone through and prepped the commands I need. And I made comments about them in the actual Dockerfile comments, but I wanted to break it down. If you are going to be building at work or something along that line, you're going to be more along the top here. I'm going to simplify it and bring it down. And I'll explain the bottom part here. We're basically saying Docker build, which means go look at the Dockerfile and start compiling it. And I want to tag it with these specific tags, that it's db2 dev c and it's version 11.1. And I want you to do it in the file system we're in. This is where everything exists. Up here at the top, you have two other things. One, if you have corporate proxies that you've got to go through at work, you're going to want to put them here, because like if you have to do the yum install process and you've got to go out to the internet to pull down the binary files, you've got to get through your proxy. Squash is actually relatively new, and it will at the very end take a look at all the various layers that it compiled to make your image and see what are redundant or not needed and throw them out and almost try to compress the image you have. It does make quite a difference sometimes, but it also slows things down. So I'm taking it out of my command here. So let's go ahead and build the image. So let's look at what I have. First thing, Docker image list. Right now I have a CentOS 7 image that's there. I have a developer C from the Docker store and an Express C that I made or downloaded a while ago. So what I want to do isn't there. And then Docker ps-a shows that I have a single container that is there. It hasn't been up that long, but it's there waiting for me if I need it. So let's go ahead and do the build and hit go. This is going to take a long time because my computer is honestly older than dirt. So I'm going to end up stop talking here in a few minutes, and I'm going to fade out and fade back in. But it's going out and taking a look at everything that we have, and then it's going to start walking through that Dockerfile line by line by line. And you can watch it as it does some of the work, because you'll see various messages come through or error messages if there are any problems. And while that's compiling, I'll show you real quick over here. You'll notice that here it's not so much. I'm really not exporting anything to the screen for you to watch or see where it is, but in my scripts I'm constantly talking to the screen or a log, so you know how far along you are, and that'll come into play later. Here we go. It just went through everything line by line. This is the point where it's going to go out and do the yum install and get all the different binaries we need and apply them. So we've gone through installing the binaries from our yum install and then expanded our db2 tar file and ended up installing it without a problem. Once that was done, we cleaned up behind ourselves and created the file system we needed before going through and creating file system persistence by using the volumes. And in the end, we exposed our port. We ended up copying over the scripts that we needed, and we finished compiling our image. So let's take a look. Now if I do Docker image list, I have a new image that's been created. Now, just because it compiled correctly doesn't mean that it runs correctly. And that's why I put a lot of echoes and writing to file in my other scripts, so you can see if there's ever a problem, and I'll show you a trick. So let's go ahead and we will take this image and spin up a container. To do that, we are just going to go over here. Normally what you would need is Docker and run, and that's what the basic is. You're going to specify the image name that you are going to use, the one we just created. But remember, I also ended up giving the ability to create a test database and setting up passwords. So this -e is basically saying pass these variables along as you go and you spin up the container. So I'm going to copy everything here. And paste it. And then the image that we want is this image ID here. So I could have also specified the repository and tag together, I believe, but I'm just in the habit of using the image ID. So I hit go. And it is taking the image and the variables I have, putting them together, and spinning up an active container. The container has been built. So if I do docker ps -a, I'm going to see a new container there that wasn't before. And it is this top one here with the name and the image that I built from. What I want to do is take a look and make sure that my logs look clean, because over here in my script, especially over in the Entrypoint script, you're going to see I'm constantly echoing, this is what I'm doing, this is what phase I'm on. I realized that I could create the Entrypoint script without a problem, but troubleshooting it was a royal pain in the butt if I wasn't echoing out to a file. So I can do docker as a docker container logs, and there we go. If I go all the way up to the top from docker container logs, and I gave the container that I just spun up, here's everything that I was doing before. You can kind of read through this, you know what we did from walking through each script one by one, but I'm going through and setting up everything that I wanted, and the fact that I'm constantly echoing out is giving me a log that I can go follow. Now, one of the things that I want to point out is, hey, you could sit here and go, oh, hey, I'm done. Well, that's not true. Remember, I always had a start and end when I did my scripts. So for example, script start. So if you didn't see a script end, it's still working on spinning this container completely up. And if I look at it again, oh hey, now we've got more. We ended up finishing, and I can see that script has been ended, and I handed it off to my last script that needed to go. Now the Entrypoint script is the only thing you can see with the container logs command. This second script is actually written out to the temporary directory of the container. So let's go ahead and go to the container ps -a. If I could type, docker, let's use docker ps -a. That'll do it. All right, so the last piece, we've compiled, we've started a container. Now I want to actually get into the container. So it's docker execute interactive terminal. The container name, so you can either use this name here or the actual name that it randomly generates for you. So I'm going to put that, and I want to flip over into just a bash command. There, I'm actually in my container now. If I wanted to, I could sudo over to db2 inst1, but what I want to see is that very last script that built out my database is here. Let's see. Everything's clean. We started with the script start here. I know it got started. It went through, created my database, made all the changes that I wanted, and got to the very, very bottom and ended. So we're clean. We compiled clean. We ended up running the container, and then we did the container logs command to see the Entrypoint script run and made sure that was clean. Then we actually went into the container and we went to the temporary directory and looked at the log file I was producing, just so I know that the database was being created and configured correctly. So that's all done. And I know that seems silly, but you've really got to know what's going on to troubleshoot. And for me, one of the big things was I was finding I was launching the container, flipping into the container and throwing off commands, and it hadn't completely spun up yet, so it would start to error. So does everything look okay? So sudo su db2 inst1 and db2 list database directory. Yep, everything's there. Is my database active? everything looks clean. So let's say I want to get out of this. And I'm going to exit all the way back out. And I wanted to point this out. I'm going to stop this. Let's go ahead and stop what I was doing. When you issue a Docker stop, that is the equivalent of a hard shutdown on a server. So you will theoretically go into crash recovery. That's why we spent so much time in the very beginning doing a lot of if-then statements. If I've already configured this, don't do it. I don't care. I don't want you to go through iterations that you don't need to go through. So I'm simulating a hard crash by issuing a stop, or you had an Abend, or it was part of another virtual layer that was stopped because maintenance had to be done. So let's go ahead and start it. Docker start. So the container is going to be up and going. And I'm going to go do, let's look at the logs again. Come on, command line recall for me. There we go. So this is what's being produced by the Entrypoint script. Notice what we have up here was the tail end of the very first run. It just basically tacked on to the end of the log. So, and you can see it break here, phase 10, and then we go into script start. Now at this point in time, it's analyzing what it's done and it's skipping it. This makes it come up a lot faster and it prevents any conflict later on. So what if I execute and get back into that container? What happened with the other script that had to build the database? You can see that it immediately started analyzing everything and had determined that it didn't need to do anything, skipped all the configuration and just activated the database. So putting in the extra time to do the if-then statement to auto-detect what was going on makes you a lot more hardened for when you abnormally end or you get an actual shutdown. If you're just doing something quick and dirty for your local, you don't probably need to do this. But if it's going into another virtual layer, like Rancher is spinning up a whole stack, you want to go ahead and put this in or you're going to drive yourself nuts later. All right, that was a lot to absorb. So I'm going to do a real quick pass on some takeaways that you must remember. These are the important points of what we just went through. First and foremost, remember everything is done in one directory. Everything is placed there, from your Docker file to any scripts you want to use to any files that need to be expanded and installed. And that when you execute your build command, you're going to be in this directory. Remember that you need to copy any files or scripts that need to be in the image. Just as if you would have to FTP a tar file from your local laptop up to the server you want to install it on, you have to do that in your Dockerfile. Essentially tell Docker to copy over the file you need into the image because you're going to be expanding it later. And that also applies to the scripts and especially your Entrypoint script. And then finally, keep an eye on those last scripts. You may have to change your permissions on them, otherwise they won't execute correctly when the image is spinning up. When you're dealing with file systems, most of the time for people that aren't DBAs, you're probably not going to have many persistent file systems. You don't care if the data survives. But if you're a DBA or this is for a database, take a look and think about what you really need to make persistent and what you don't. Otherwise, you can have a problem if things abnormally ended or you need to stop and restart the container. Remember to try to make things resilient and especially flexible. If this is quick and dirty on your local and you really don't care, it doesn't matter. But start thinking ahead. If this is going to be part of a larger stack that's virtual, things could be started and restopped, or the system administrator that's in control of the virtual stack doesn't realize what you're doing. He may actually go out and make changes for you. So just try to be flexible and put things in with an if-then statement. Double check, do I even really need to do that? If you are going to pass variables and it's going to be going past the Entrypoint script into other scripts, you're going to end up exporting the variable name. If you don't, the variable doesn't get passed out to the next script that's going to want to use it. And remember that at some point in time, either at the end of your Dockerfile or in the end of your entry point, somewhere before you are completely done, you need to tail something perpetually or cause the image to do something perpetually. Otherwise, it's going to immediately launch and then stop because it completed everything that you wanted to do. And finally, for those that are DBAs, if you're going to be working with DB2, you most likely will need to use the privileged switch when you do your run. You don't always have to do it. There are other ways around it, but it's just the easiest way to go about it. And finally, remember that a stopped container is essentially a hard crash to DB2. The system just went away and you didn't shut things down nicely. So if you are making this more versatile and it needs to be able to restart and go back in, that's when you're keeping in mind that you want persistent volumes that we talked about earlier, but then make sure things aren't dorked. You know, what would you check on a system that just crashed, or do I have rogue things in memory? So maybe I need to do an IP clean. For some reason with Docker, the ports sometimes disappeared on us, so we had to check to make sure that the ports were there, and if not, put them back. And then don't assume that you can go into crash recovery. So issue the DB2 start and go ahead and activate things explicitly. But if you keep an eye on those last items, you're going to find that you can come up without too much of a problem, and DB2 will crash recovery without issue.